Question number 1. The equation of the curve y equals 2 cos x plus sine 2x. Find the x coordinate of the stationary point on the curve for which x is between 0 to pi and determine the nature of each of these stationary points. So for stationary point, we're going to find dy by dx and then equate it to 0. Okay, so 2 will stay 2. Derivative of cos x is negative sine x plus derivative of sine 2x is cos 2x times 2. So 2 cos 2x is equals to 0. We can divide 2 on both sides. So negative sine x plus cos 2x is equals to 0. Okay. From trigonometry, we know that cos 2x can be written as 1 minus 2 sine square x. This is also given in the formula sheet equals to 0. Now we get a quadratic equation in terms of sine x. I'm going to multiply both sides with negative 1 as well. So I'm getting 2 sine square x plus sine x minus 1 equals 0. Now I'm going to factorize this using middle term breaking. So the factors would be 2 and 1, 2 and negative 1. So break the middle term, plus 2 sine x minus 1. Take 2 and sine x common, we get sine x plus 1. And take negative 1 common and we again get sine x plus 1 equals 0. So 2 sine x minus 1 and sine x plus 1 equals 0, which gives sine x equals negative 1, sine x equals 1 over 2. All right, now we're going to find the values of x. Okay, for sine, let's find the reference angle for this one. It's going to be shift sine half in radians. So shift sine half is pi by 6. So the reference angle is pi by 6. Okay, sine is positive in the first quadrant and the second quadrant, so pi by 6 here and pi by 6 here, both are in the domain, which is 0 to pi. So one value of x is pi by 6 and the other value of x would be pi minus pi by 6, which would be 5 pi by 6. 5 pi by 6. All right, from here, let's find reference angle, which will be shift sine 1. We always find reference angle for positive value. This is going to be half pi. So half pi when sine is negative is going to be in this quadrant and this quadrant. So half pi here, half pi is actually 90 degrees. So I should technically make it here. So it's on this line. So in this quadrant, now this angle is outside of this domain. So we can't take this angle or this angle. So negative 1 or sine x equals to negative 1 will not be part of finding our solution. So our values of x are pi by 6 and 5 pi by 6. So now we're going to determine whether this stationary value is positive or negative. Okay, for stationary value, we're going to find second derivative. So this was the first derivative. Let me write that again. So dy by dx equals, remember the 2's with this expression. Do not take this as your first derivative. That would be wrong. All right. So now we find the second derivative, do d square y about over dx square. That's going to be minus 2. Derivative of sine x is cos x. And derivative of cos 2x is 2 times minus sine 2x. So it's going to be minus 4 sine 2x. That's the second derivative. Now we're going to substitute the values. of x and see whether we get a positive value or a negative value, determining whether it's going to be a minimum or maximum. Okay, so when x is equals to pi by 6, substitute that in the second derivative, you will get d square y upon dx square equals negative 3 under root 3, which is less than 0. So that's a maximum stationary point. And when x is pi by 6, sorry, 5 pi by 6, then d square y upon dx square will come out to be 2.46, which is greater than 0. So this value is going to be a minimum.